Thermal spraying, applying a thin layer of molten materials on a desired object. The science of thermal spraying has risen from an almost anonymous aid for corrosion maintenance and prevention into an indispensable metalworking tool. Pure or alloyed metal is melted in a flame and atomized by a blast of compressed air into a fine spray. As it builds up onto a previously prepared surface, the spray forms a solid metal coating. As the molten particles strike the selected surface, they flatten and form thin platelets which adhere to one another, forming a dense, functional protective coating.
And it's very popular in all the industrial aspects as far as hydraulics, aircraft, marine, automotive, trucks. It lends itself to just about every industrial application you could think of.
Thermal spraying, or metallizing, is commonly used for machine element work. It builds up worn parts, salvages mismachined parts, and builds corrosion resistance on many structural steel elements. Machine element work requires a strong bond between the sprayed metal and the base metal. In order to obtain this bond, a certain amount of preparation is required. On a shaft, for example, the operator must first degrease the part with a solvent so that it is clean. The shaft is then undercut to provide space for the sprayed metal. Once that is done, the operator can begin to apply a bond coat to the surface. On top of that bond coat, the part is then completed by machining it or grinding it to size. Studying the requirements of each machine element job is a necessity. Every job will be different, so selecting a bonding method will also be different. Preheating, roughening, and spraying are the three basic methods used, all designed to achieve different end results. Selecting the proper metal is a very important step in assuring the successful completion of a job. Each metal has different characteristics of bond strength, shrinkage, hardness, as sprayed finishes and machine finishes. So there is a metal for almost every application.
For example, aluminum would be chosen for its corrosion resistance in salt and sea atmospheres, whether it's submerged or it's at the tide line or it's just in the atmosphere. Also, it would be used in certain contact with foods.
The structure of sprayed metal deposits is strongly influenced by many variables, and modern equipment affords complete control over spraying conditions. The operator has the ability to know the physical properties and is able to consistently reproduce identical deposits, including the properties of the metal particles, the cohesiveness of the particles, the strength of particle attachment, the degree of porosity of the structure, and the effect of the oxide content. Sprayed metal has a different structure from that found in cast, rolled, or drawn metals. As the small molten particles are sprayed from the gun, they strike the surface, flatten out, and cool almost instantly, creating the buildup of a slightly porous structure of small, flattened, interlocking metal particles. This unique structure results in a change of physical characteristics. On the one hand, the ductility, elongation, and tensile strength are greatly reduced when compared with the same metal in cast form. On the other, wear resistance usually exceeds that of the same metal in cast form.
A fine oxide content plus the rapid quenching makes these more work hardening and better performing as compared to the properties of a wrought or cast coating. There is some.
The time that elapses between preparation and spraying should be held to a minimum. No hard and fast rules can be laid down, but in very damp atmospheres, iron or steel should be sprayed immediately after preparation. If the atmosphere is very dry, iron or steel should be sprayed within 3 or 4 hours of preparation. When spraying outside diameters, such as shafts, each successive layer cools and contracts. Consequently, the sprayed metal coating is tightened on the shaft in a manner similar to the shrinking on of a sleeve. When spraying inside diameters, however, the shrinkage of the sprayed metal weakens the bond. Therefore, much greater care must be exercised in preparing and spraying inside diameters. When sprayed metal is applied to a flat surface, a tensile stress is set up in the coating. This results in a compressive stress at the surface of the base material. Care should be used if the base material has a thin section, as velocities and overheating may create warpage. Here, the use of auxiliary cooling will be beneficial. If the base material has a heavy section and is able to resist deformation, the stresses set up by cooling will tend to lift the coating at the edges. Therefore, it is essential that careful consideration also be given to the preparation of flat surfaces.
On a flat piece where the edges are, it's most critical to make sure that you blast the perimeter of the edges, because that's where it may be the weakest point for lifting or spalling, or where a pickup may take place.
Stresses due to cooling will increase as the thickness of the coating increases. Consequently, there is a practical limit to the thickness which can be applied to inside diameters and flat surfaces. The effect of these stresses is also influenced by the ductility of the metal being sprayed. Very heavy coatings of softer metals can be applied without any bonding difficulties. However, the same thickness of coating using copper alloys or steels will cause difficulty. In order to minimize these effects, when spraying inside diameters, the work should be preheated. This serves to expand the diameter before spraying, so that less stress is imposed on the bond. Securing and maintaining maximum spraying speed is essential in reducing the variation of coatings. Be sure to follow these guidelines. Set the regulators at desired pressures and flows, then light the gun in the usual manner. Slowly increase the speed of the wire until the gun is atomizing rather than spattering. Slowly raise and lower the oxygen pressure while watching the melting end of the wire. The wire should protrude out the front of the gun about 1/8 of an inch, maintaining a fine point. Recheck your pressures and flows while the wire is feeding to see that you are maintaining your set parameters and the proper wire feed. Use of a flow meter is a practical necessity for balancing the flame. Some shafts contain keyways, a slot in a shaft that acts as a cylinder lock, which could present a series of problems that can be troublesome if not approached in the correct manner. Sometimes it might be difficult to secure a bond along the edges of the keyway that is strong enough to eliminate the tendency of the interrupted coating to lift. In addition, difficulties may arise in adequately masking the keyway itself, so that finishing the edges after spraying can be done without machining.
You would put some kind of silicone rubber or some kind of compound to protect that keyway, and then when you blast, you would blast right to that edge of the keyway. Thus, the coating would wrap around that edge. And so
the tension developed in a sprayed metal coating increases in proportion to the thickness of the coating. As a result, there's a strong tendency for the edges of keyways, which interrupt the continuity of the coating, to lift. In order to secure an extra strong bond, preparation must include special attention to edges. Shafts containing keyways should be undercut and then metallized using grooving, grit blasting, and wire. Overhanging burrs and rough edges are then removed from the keyway with a flat or square file. Once the keyway has been prepared, the next step is to mask the keyway in a way that will eliminate remachining. This general procedure remains constant for all keyways. However, variation is commonly found in the methods of masking. Wood, bakelite, carbon, and soapstone can be used. Masking tape and masking compound are also very effective methods used to protect an abundance of many surfaces from the metal spray. Although sprayed metal coatings are porous, it is not always necessary to seal up these pores. For ordinary build-up work on machine elements, the coatings usually run on lubricated bearings. Here, the porosity is a great advantage since it retains oil. This oil seals the pores and prevents moisture from entering. For most purposes where stainless steel and Monel are used, it is not necessary to seal up the pores either. These coatings are sufficiently thick enough to be relatively impervious to the penetration of moisture. However, in cases where thin coatings are used, where the corrosive reagent is quite active, or where high pressures will be used, it is best to seal up the pores in the sprayed metal coatings. Metco 185 Sealer and Metco Seal AP can both be used as sealants to protect a sprayed shaft. Final step in flame spraying a part is finishing. Experimentation and research indicate that with understanding and appreciation of the characteristics of sprayed metal, both machining and grinding can be accomplished in the tool room or on the production line with less trouble than is caused by many alloy materials in solid or wrought form. Sufficient working data for both machining and grinding have been established to permit production finishing of all of the commercially used metals that have been developed for metal spraying. Naturally, some finish better than others, but commercial tolerances can be obtained on all.
Most customers would use like a K46 aluminum oxide open wheel for grinding. If the material's harder, they would then go to a silicon carbide wheel, and where they would want a very good finish and a micro-inch finish, they would then go to a diamond wheel.
Once the operator has completed the grinding stage, the shaft is ready to be cleaned and polished. Thorough scrubbing and rinsing with a suitable solvent diminishes the possibility of abrasives in the surface pores of the metal. When used to salvage a mismachined part or undersized casting, thermal spraying can restore dimension, using a material equivalent to the original material, at a fraction of the cost necessary to completely refabricate a new part. In remanufacturing, thermal spray coatings quickly restore components to their original OEM specification. Using a coatings recommendation system, specific coatings can be chosen to deliver virtually any desired type of surface performance.